Array. Move zeros to end. In this problem, we are given an array. For example, 0, 1, 0, 3, 12. We have to move all zeros to the end of the array. The order of non-zero elements should not change. In the original array, the non-zero elements are 1, 3, and 12. So in the final answer also, they should come in the same order, 1, 3, and 12. So the output will be 1, 3, 12, 0, 0. Now let us solve this using method 1. In this method, we use another array. We create a new array called result. This result array will store our final answer. First, we go through the original array from left to right. The result array has 5 places because the input array also has 5 elements. Now we start checking each element one by one. First element is 0. Since this element is 0, we simply move to the next element. Next element is 1. 1 is not 0. So we add 1 to the result array. Next element is 0. Since this is 0, we move to the next element. Next element is 3. 3 is not 0. So we add 3 to the result array. Next element is 12. 12 is not 0. So we add 12 to the result array. At this point, we have checked all elements in the input array. We have added all non-zero elements to the result array. So now we fill the remaining places with zeros. Now the final result array is 1, 3, 12, 0, 0. So the main idea is simple. First, copy all non-zero elements, then fill the remaining places with zeros. Now let us convert the algorithm into pseudocode. Step 1. We write a function that moves zeros to end with array as the input. Inside the function, we create an empty result array. Step 2. Now we go through the original array for each element in array. This means we will check every element one by one. Step 3. Whenever we see a non-zero element, we add it to result. So inside the loop, if element is not 0, add element to result. This means zeros are not added here. Only non-zero elements are copied to the result array. Step 4. After all non-zero elements are added, we add zeros at the end. We keep adding zeros until the result array size becomes the same as the original array size. While size of result is less than size of array, add 0 to result. Finally, we return result. That is the complete pseudocode for method 1. First, we collect all non-zero elements. Then, we fill the remaining positions with zeros. Now we have the pseudocode on the left side. On the right side, we will write the actual code. We will convert this into Python, C, Java, and Go. Let us start with Python. First, we write the function definition. The input array is passed as argument to the function. Then we create an empty list called result. Now we write the for loop to go through every element in array. Inside the loop, we check if the element is not 0. If it is not 0, we append the element to result. After the loop, result contains only the non-zero elements. Now we add zeros at the end. We keep doing this while the length of result is less than the length of array. Inside the while loop, we append 0 to result. Finally, we return result. That completes the Python code. Now let us convert the same idea into C. First, we write the function definition. In C, we pass the array and its size as arguments. Then we allocate memory for the result array. We also create result size and set it to 0. Result size tells us the next position in the result array. Now we write a for loop using index I. Inside the loop, we check if array of I is not 0. If it is not 0, we store array of I at result of size. Then we increase result size by 1. After the for loop, all non-zero elements are added. Now we add zeros at the end. We keep doing this while result size is less than size. Inside the while loop, we store 0 at result of result size. Then we increase result size again. Finally, we return result. That completes the C code. Now let us convert the same idea into Java. Create a new integer array with the same length as array. We also create result size and set it to 0. Now we write a for each loop to go through every element in array. After the loop, all non-zero elements are added. Now we add zeros at the end. Finally, we return result. That completes the Java code. Now let us convert the same idea into Go. Create an empty integer slice called result. Now we write a range loop to go through every element in array. After the loop, all non-zero elements are added. Now we add zeros at the end. Finally, we return result. That completes the Go code. The idea is the same in all 4 languages. Create result. Copy the non-zero elements. Add zeros at the end. Return result. Now let us solve the same problem using method 2. This is the in-place method. In-place means we use the same array. This is the main improvement in space usage over method 1. We start with the given input array. We create a variable called insertPosition. InsertPosition tells us where the next non-zero element should be placed. Initially, insertPosition is 0. Now we go through the array from left to right. The current element is 0, so we move to the next element. Now the current element is 1, which is a non-zero element. So we copy 1 to insertPosition, and then increment insertPosition. Now the current element is 0, so we do nothing and with 0 and move to next element. Now the current element is 3, which is a non-zero element. So we copy 3 to insertPosition and then increase insertPosition by 1. Now the current element is 12, which is a non-zero element. So we copy 12 to insertPosition and then increment insertPosition. Iteration over the array is complete. At this point, all non-zero elements are placed at the beginning of the same array. Now we fill the remaining positions with zeros. InsertPosition is 3, so we place 0 at index 3. Then we move to the next position. Now we place 0 at index 4. So in the inPlace method, we use the same array. First, we copy all non-zero elements to the front. Then we fill the remaining positions with zeros. Now let us convert the inPlace algorithm into pseudocode. We write the function, move zeros to end with array as input. Inside the function, we create insertPosition. InsertPosition tells us where the next non-zero element should be placed. Initially, insertPosition is 0. Step 2. We write a loop. Current position helps us check each element one by one. Current position starts from 0 and goes up to the last index of the array. Step 3. If current element, which is array of current position, is not 0, we copy the current element to insertPosition's place and increment insertPosition by 1. After this loop, all non-zero elements are copied to the front of the same array. Step 4. Now we need to fill the remaining positions with zeros, so we write a while loop. While insertPosition is less than the size of the array, we place 0 at insertPosition. Then we increase insertPosition by 1. Finally, we return the same array. So this is the complete pseudocode for the inPlace method. Now we shall write the same logic in different programming languages. The Python code follows the same idea. Use insertPosition. Move non-zero elements to the front. Then fill the remaining positions with zeros. Next, we are writing the code in C. The logic is still the same. We use the same array. We update the values directly inside the array. Next, we are writing the code in Java. Again, we use insertPosition. We copy each non-zero element to the correct position. Then we fill the remaining positions with zeros. Finally, we are writing the code in Go. The same in-place logic is used here also. So in all 4 languages, the idea is the same. Use the same array. Move non-zero elements to the front. Fill the remaining positions with zeros. Now let us quickly compare both methods. For method 1, we go through the array once, so the time complexity is O of n. Method 1 also creates another array to store the answer, so the space complexity is also O of n. Method 2 is the in-place method. The time complexity is still O of n, because we still go through the array. But the space complexity is O of 1, because we do not create another result array. We modify the same array directly, So both methods take linear time, but method 2 is better in space usage. That completes our explanation of moving zeros to the end of an array. We first understood the problem, then we solved it using another array. After that, we improved the solution using the in-place method. Thank you for watching. If this video was helpful, please like the video and subscribe to Program Guru for more videos on data structures and algorithms.